Welcome back to part 2 of our lesson where we are looking at quadratic equations. In this lesson, we are going to focus primarily on using the formula to solve quadratic equations, but we're also going to look at how to use the factoring technique, how to use completing the square, and then use most of our time to deal with the formula. First issue is, where does the quadratic formula come from? The quadratic formula comes from the process of completing the square on the general form of the equation ax squared plus bx plus c equals 0. When we apply the principle of completing the square to this equation, the resulting answer that we get at the end is the quadratic formula. CXE does not and will not ask the student to prove the formula using this process. It simply will ask you to use the formula or use any method available to you to solve a given question. The formula can solve all types of quadratic equations, and so can completing the square. Sometimes it is not necessary to use the formula. The formula is more of a sledgehammer, where sometimes what you need is a scalpel. So we are going to look first at how to solve a quadratic equation by factoring. If you do not understand how to factor, then you should watch the video on how to factor trinomials. If you have done that, or if you have experience, then you can follow along and we can work this out together. So solving this equation, 3x squared minus 7x plus 2, our first thing to do would be to write down our a value. Our a value is 3, our c value is 2, and what we're going to do is multiply these two values together. So we multiply 3 times 2, that gives us 6. The other numbers that multiply to give us 6 are 6 and 1. And one pair of these numbers will combine to give us the middle term. This pair of numbers can combine to give us the middle term if we use both of them as negative. So negative 6 and negative 1. If we multiply negative 6 by negative 1, we get a positive 6. And if we add negative 6 to negative 1, we get a negative 7. So this is the pair of numbers that we need to split this middle term into 2. So now we are going to rewrite this middle term using both these terms. So we're going to write 3x squared minus 6x minus 1x, or just minus x, plus 2 equals 0. Once we've done that, we group our terms together and we factorize. So the common factor here is 3x. We can divide 3x out from this bracket. This leaves us with x minus 2. And we can take out a minus 1 from here, and that leaves us with x minus 2. Notice our brackets are the same, so we can write our outside factors in one bracket, 3x minus 1, and write back the other bracket, x minus 2. That should give us 0. Now, what this form says is this bracket multiplied by this bracket gives us a 0. That can only happen if this bracket or both are 0. So individually, we write them out to be equal to 0. So we have 1, 3x minus 1 equals 0, and 2, x minus 2 equals 0. In this case, we solve the simple linear equation. 3x is therefore equal to 0 plus 1, which means 3x is equal to 1, and therefore x is equal to 1 over 3. And in this case, x is equal to 0 plus 2, so x is equal to 2. Our solutions to the quadratic equation are therefore x is equal to 2 and x is equal to 1/3. If you're good at factoring and you have a lot of experience doing it, then sometimes you can look at a question and decide whether or not it can be factorized simply by just inspecting it. In an exam, however, you may not have the time to check if a question can be factorized. And usually a question does not say solve by factorization. When a quadratic equation is given, it simply asks that you solve it, and you, the student, will choose your method and solve it according to how you want to solve it. Now, let's look at how to solve a quadratic equation by completing the square. Usually, when you're asked to use this method to complete the square, it's usually a part of another question. So for example, here, this question says write 3x squared plus 12x plus 25 in the form a bracket x plus h squared plus k. So we must complete the square on this expression. And having done that, it says hence or otherwise, meaning that we can use another method to solve it, or we can continue onward from what we found. First, let us write this expression in that form. 3x squared plus 12x plus 25. First, we separate these two terms. Then, let's factor the 3 from the bracket. 12 divided by 3 gives us 4x. Then, we find half of this term, which is 2. Half of the 4 is 2. We square it and add it to the bracket. And we subtract it from the 25 times the 3. So now we have, in factoring everything, x plus 2 square plus 25 minus, this is going to be saying 25, take away 2 2 is 4, 3 4 is 12, 25 take away 12 is 13. So our result here is 13. So we have rewritten this expression in that form. This answers the first part of the question. The second part of the question says hence or otherwise, which means having done this, solve this equation. So let us use this expression to solve the equation. You could also use the formula approach to complete the square on this, and you can find that in a previous video on completing the square. Now, we have the second part of the question, which says hence, solve, or otherwise, which means you could use the formula or something else. We are going to use the hence, so we are going to continue on from this, because here we want to show how to use completing the square. So we have 3x plus 2 square plus 13, which is what this is equal to 40. Now the first thing we can do is to remove the 13 to the other side of the equation. So let's do that. X plus 2 square is equal to 40 minus 13, and that gives us 27. So we have 3 into x plus 2 square equal 27. And then we can divide both sides by 3. This now gives us x plus 2 square equal 9. The solution to this type of question was done in the first video. You can watch it to see how that works. But how it works here is that we take the square roots of both sides. So we say the square root of x plus 2 square is equal to the square root of 9. And this will give us two equations. X plus 2 is equal to plus or minus 3. Solving these two equations gives us our answers. So x plus 2 equal 3 and x plus 2 equal minus 3. Solving this one gives us x is equal to 3, take away 2, which means x is equal to 1. And solving here gives us x is equal to minus 3 minus 2, which means x is equal to minus 5. So our solutions to this equation would be x is equal to 1 and x is equal to negative 5. And that is how we would apply the completeness of the square method to solve an equation. Now, how do we use the formula? When we're using the formula, and this is what the formula is, minus b plus or minus the square root of b squared minus 4ac over 2a, we need to make sure that our equation is in standard form. That is, our equation is written in the form ax squared plus bx plus c equals 0. This equation is not in that form. So let us remove the 9 from this side to the other side. So we can have 2x squared plus 5x minus 9 equals 0. Now let's write down the values of our letters. Our A is 2, our B is 5, and our C is -9. Now we're going to substitute all of these values into this formula. Formula is minus B plus minus square root of B squared minus 4AC over 2 times A. Doing that substitution, we end up with minus B, which is minus 5, plus or minus the square root of B is 5, so we have 5 squared, minus 4 times A is 2, times C, which is -9, and we write all of that over 2 times A, which is 2 times 2. This gives us -5 plus or minus. And what we need to do now is to find what this number is. 5 squared minus 4 times 2 times -9. That number is 97. So we are going to write down our 97. All of it divided by 4. And now we need to find the square root of 97. The square root of 97 turns out to be 9.8. So we have -5 plus or minus 9.8 or 9.9, 9.84. It's actually 9.8 over 4. And we use this expression to get our two answers. So we're going to have -5 plus 9.8 over 4 and -5 minus 9.8 over 4. When you're doing this section, be careful how you use your calculator. A lot of persons make mistakes here by writing out in their calculator -5 plus 9.8 divided by 4. This is a common mistake that you should try to avoid. Once you do this, the calculator is going to work out this part of the expression first, then add the result to -5, and it will give you a wrong answer. So rather, work out the top first. At the top, we're going to get -5 plus 9.8, which is positive 4.8. And then we divide that by 4. And in this expression over here, we have -5 minus 9, which is -14.8 divided by 4. Once we divide these, 4.8 divided by 4 gives us 1.2, and -14.8 divided by 4 gives us, which is 12, 13, that leaves us 14.8 divided by 4, which is 12. We subtract, we have 2, we put a point, and this gives us 7. 4 sevens are 28, and we're finished. So we have 3.7, -3.7. The question had said, write the answers to two significant figures. These answers are correct to two significant figures, 1. So our solutions to this question are x is equal to 1.2 and x is equal to -3.7. That is pretty much how we use the formula. Once you have a calculator in hand, using the formula is pretty simple, because you simply, once you have it, you substitute your numbers into the formula, and after that, everything else is just number work, which your calculator should be able to manage. Let's look at another one. In this question, we are asked to write all the answers without using a calculator. Notice that the square root of 5 sign is written. So we are asked to show that the solution to this equation, the roots, remember these answers to a quadratic equation are often called roots. So we're supposed to show that the solutions to this are these. Well, let's write down our values. The coefficient of the x squared here is a is 1. The coefficient of our b term is -3, and the coefficient of our c term is 1, or constant. So we've put those into the formula. The formula is minus b plus minus the square root of b squared minus 4ac over 2a. And we're simply going to put these values in. So we have minus b, which is minus -3, plus minus square root of b squared, which is -3 squared, minus 4 times a, which is 1, times c, which is also 1. And all of that over 2 times a, which is 2 times 1. Now this gives us the negative of -3 is 3, plus or minus the square root of 9, take away 4. And all of that over 2. 9 take away 4 is 5. So we have 3 over 2. 3 plus or minus the square root of 5 over 2. And as you can see, that's exactly what this is. So we can rewrite it as 3 over 2, this 3 over 2, break it apart, plus or minus the square root of 5 over 2. And in this case, you do not use a calculator because the question would have asked you to write the exact answer with the square root sign. If you should use a calculator, then it's going to totally mess up this thing that the question had asked you to find. Sometimes the questions are written like this, and they are not in standard form, as in they're not in the form ax squared plus bx plus c equals 0. So you want to make sure that you rearrange the question to get it in the form. So we have 2x squared plus 2x minus 8. Regroup these on the other side of the equation. We get a minus 3x plus 6 equals 0. So we can rewrite the equation as 2x squared. This 2x and this minus 3x gives us a minus 1x, or you can just write minus x. And this minus 8 and plus 6 gives us a minus 2. And that should be equal to 0. And then this is our equation in standard form. And you can go ahead and use the formula to solve. Sometimes the questions are given in this way as well, where you have to multiply the bracket first. So we have 2x multiplied by x minus 7 plus 3 multiplied by x minus 7 equal to 4 into x minus 7. So we have 2x squared minus 14x plus 3x minus 21 equal 4x minus 28. And then we regroup as we did previously. So we have 2x squared minus 14x plus 3x minus 21 minus 4x plus 28 equal 0. Now we can write our terms. 2x squared, this term, all the x terms together, is saying minus 14 plus 3 minus 1 minus 4. This gives us minus 14x plus 3x gives us minus 11x, and minus 11x minus 4x gives us a minus 15x. Negative 21 plus 28 gives us a positive 7, and this would be the equation in standard form. And now that we have it, we can use that formula to go ahead and solve it. Sometimes a quadratic equation will come in some form looking like this, and in this case we do not require a formula to solve it. What we require is some algebraic manipulation. So find the values of a and k such that a squared plus x plus k is equal to this. Then since we know that x plus a squared is equal to x squared plus x plus k, then what we need to do is to expand this and see what it's equal to. So let's expand it. X plus a times x plus a gives us x squared plus ax plus a squared, which simplifies down to give x squared plus 2ax plus a squared, and this is identical to or equal to x squared plus x plus k. Now, what we can see here is that this x squared is equal to that x squared, which is fine. This 2ax is equal to this x, which means that the coefficient of the x here being 1 is equal to the coefficient of the x here being 2a. So we can write 2a equal 1, since both coefficients should be equal to each other. And if 2a is 1, then a is going to be equal to 1 over 2. So we have found that value of a. Next, we want to find the value of k. Now, from this, we can see that a squared is actually equal to k. So we have a squared equal k, and we know the value of a. A is a half, so half square is equal to k, which means that k be equal to 1 over 4. So a question like this would not need any formula or factorization. It just needs a little bit of algebraic manipulation where we expand the bracket and align the values to see what is equal to what. So let's write it again. This expression leads to x squared plus 2ax plus a squared, and we are told that it's equal to x squared plus 1x, because the coefficient here is 1, plus k. So you can see that this term is equal to this term, and that term is equal to that term. And once we line them up, we can do the manipulation and simple equations and get our value. Okay, we now look at our final question. Here we have two rectangles, or two our squares, in the diagram below, not drawn to scale. AKLM and ASJTJ are both rectangles. So we have AS. AS is equal to 3x. We can write those in. AS is equal to 3x. That's from here to here. AJ is equal to 2x. That's that section there. SK is 3. So that's here. And JM is 5. We are now told to obtain an expression in terms of x for the area of rectangle AKLM. That's AKLM. That's part 1. The area of a rectangle is usually found. We find it by multiplying the length times the width. So we have, for the length, or base and height, 3x plus 3, and 2x plus 5. And that suffices for the area of the rectangle. Given that the area of the rectangle AKLM is 60, as part 2, given that the area is 60, show that 2x squared plus 7x minus 15 equals 0, which means that we are supposed to simplify that equation, form it and simplify it. So let's write it out. 3x squared plus 3x plus 3 times 2x plus 5 is equal to 60. Multiplying it out, 3x times 2x gives us 6x squared. 3x times 5 gives us 15x. 3 times 2 here gives us a 6x. And 3 times 5 here gives us a 15. That is equal to 60. So we can write 6x squared, bring these two together, plus 21x, and bring the 60 to the other side, plus 15 minus 60 equals 0. Remember, we want to show that is equal to this. So we have 6x squared plus 21x minus 45 equals 0. Now this equation is what we have, but it does not yet look like this. But if you look at it carefully, you can realize that you can divide it by 3. And if you divide by 3, then 6x squared divided by 3 gives you 2x squared. And 21x divided by 3 gives you 7x. And 45 divided by 3 gives you minus 15. That's minus 45 divided by 3. Now this is the answer that we have, and it is what the question says. So both expressions are the same. So we have succeeded in showing that the expression is actually this. That is the equation that is the area of the rectangle. Hence, we are told to find the values of x and state the lengths of AK and AM, which means that we need to solve this equation. 2 times 15 is 30. Let's try to see if it can be factorized. Other numbers that multiply to give us 30 are 5 times 6. We have 10 times 3. Those multiply to give us 30. And immediately we can see that this pair will work with that, because we can use this pair to get 7. So we can rewrite our expression as 2x squared plus 10x minus 3x minus 15 equals 0, and factor it out. So we end up with 2x, bracket these two to factorize, 2x into x plus 5, and minus 3 here into x plus 5, which gives us 2x minus 3 and x plus 5 equals 0. Once you solve this by setting each of these equations to 0, so we have 2x minus 3 equals 0, and x plus 5 equals 0, we see that x here is going to be equal to 3 over 2, or 1.5, and x here is going to be equal to negative 5. So we get two solutions, 1.5 and negative 5. The question is asking us for a length, and the trouble is, when it comes to length or area, we cannot use our negative values. So these are our two solutions to the question, but we are going to ignore this one because we cannot use a negative length. Therefore, the x value that we choose to use is 1.5. Looking at our AK, this is AK, and this is AM. Now, AK is equal to 3x plus 3, which is equal to 3.5, not 3.5, 3 times 1.5 plus 3, and 3 times 1.5 is equal to 4.5 plus 3, which is equal to 7.5. So that's the value of AK. The value of AM is 2 times 1.5 plus 5, which is 3, plus 5, which will be equal to 8. So AK would be equal to 7.5 centimeters, and AM would be equal to 8 centimeters. It is important that we spend some time and go through this again. So in your free time, you should probably watch this video at least one time, at least 2 times. Usually, CXC will not tell you what method to use to solve a question. As I said before, you will simply be asked to solve a given quadratic equation, unless some situation like this is presented where you are told specifically that your answer should look like this, in which case you know that you cannot use factorization. You have to use a formula to get it in this way, and this equation could not be factored anyway. So my recommendation for most students is some equations can be factored, not all can be factored. So in streamlining your study, you may want to spend some time to get used to the formula because it solves all types of equations. Whether it can be factored or not, the formula can solve it. So you may not want to spend time in an exam trying to factor a question only to realize that it cannot be factored and thereby wasting precious time when you could have used the formula to solve it. You do not also need to memorize the formula because the formula comes on the formula part of the question paper. So your sole aim should be to get familiar with it, to know how to use it, and to know how to get your results from it. So in this lesson, we talked about how to use different methods to solve quadratic equations, how to use the, the factorization method by factoring this expression and getting our solutions, how to complete the square and use it to solve a given quadratic equation, and how to use the formula to solve a given quadratic equation. I hope that you would have made sense of the video. Continue to work hard as you prepare for your exams, and all the best in your studies.